This is a simple single-track railroad. The trains come in from the right and have to stop here. Now we got a switch here. The trains can either take the top track or the bottom track. So the question is, where do we build a station? We can of course give every track its own station. That means we have to build 2 of them. And that's not the most efficient solution. Now we know, whatever track we take, we always end up at the track after the switch. That should be a more obvious solution. You're probably thinking by now, why is this guy talking about tracks, trains and stations? I thought we were here to talk about programming. Well, you're completely right, but this is about programming. We've just written our first program, and now we're zooming in on a very small snippet of it. Let's call the top track if G equals S and the bottom track else. You see where I'm going? Now let's bring in the actual statements that are executed at each track. There's one statement that is executed on both tracks, the end statement, which terminates the program. That's the station we actually build twice. And we've seen that's not the most optimal solution. So where do we place the station? Right, after the end if switch, where both tracks meet again. That's where we place our station. Try to predict in which order which statement is executed. You'll find that whether we build 2 stations or one single station, both tracks do absolutely the same. Now, maybe you said I'd place the station before the switch, and you'd be absolutely right. But when it comes to programming, that's true as well, but it's a bit more complicated. Take a look at this small program. There are lots of similar statements. And we're going to clean this baby up by applying some simple rules. First of all, we're going to take a look at all the statements that are identical at the beginning of the if clause and the beginning of the else clause. Now, let's take these out and place them at the very beginning of our improved program. We repeat this for all the statements that are identical at the end of the if clause and the end of the else clause, and place those at the very end of our improved program. Now let's strip this program from all the statements we took. And let's see what's left. We place this residue in the middle of our improved program. Now let's join up the parts. Maybe you won't believe it, but these programs do exactly the same thing. But the right one is not only smaller, but also much easier to read. Why? Because it's completely clear which statements are actually conditional, and which part are always executed no matter which path is taken. This process is called refactoring. It's part of a very important principle in programming called don't repeat yourself, or eliminate as much identical code as you can. We'll be revisiting this principle again in the next lesson. And that's the end of the line, folks.